Okay, here's a really quick review on some of the operations of rational expressions. Remember that with fractions, if you multiply two fractions, you multiply the numerators, you multiply the denominators, and of course you see if it simplifies. When you divide fractions, you multiply by the reciprocal of the divisor, or as my sixth grade teacher, Mrs. Turner, used to say, you invert and multiply. So then you use the rules for multiplication after you've inverted the divisor. And I have an example here of a division which kind of covers both multiplication and division, because I am going to rewrite this as a multiplication problem. My very first step here is to invert the divisor, but I'm kind of a lazy guy and I noticed that my numerators and denominators look like they factor. So as I invert my divisor, I'm going to do some factoring at the same time. This is a difference of cubes. This is y minus 3 times y squared plus 3y plus 9. My denominator here is a difference of squares. It's not in descending order, but I can deal with that here. This is going to be 3 minus y times 3 plus y. Don't forget those conjugates. Now I'm going to change this to multiplication. My numerator is now going to be the denominator of this. So the y squared plus 8y plus 15 is going to go on top here, but that factors to y plus 3 times y plus 5. My denominator is the numerator of the original divisor here, so that's going to go down here. Now I can see it has a GCF of 5. So I'm just going to kind of write that down here. If I factor out a GCF of 5, I'm going to get something that looks like that. So 5 times the quantity y squared plus 3y plus 9. The reason I wrote it down up here is I wanted to see if this may be factored further, but I can tell it does not. But that's okay, because I see some common factors. I see this trinomial factor with this trinomial factor. I have a y plus 3 here, I have a 3 plus y here. These are the same thing, even though they're turned around, because we know multiplication is, or excuse me, addition is commutative, so I can go ahead and cancel those out. Now it doesn't look like it can cancel anything else, and I definitely cannot cancel the 5s. This 5 is a factor, but that 5 is a term. However, the little trick that I was showing you in the last video with the opposites, y minus 3 and 3 minus y are opposites of one another. So I can do the -1 trick here, cancel that out with a 1 and that out with a -1. So up top I have -1 times 1 times 1 times y plus 5. Well, that -1, I'm just going to set that out in front of my fraction. And the 1 times 1 times 1 times y plus 5 is y plus 5. In the denominator, I have 1 times 1 times 5 times 1. That's just 5 right there. Actually, let me write it right here, because I am chewing up some of my space, I think, for the next example. So that would be my answer. Now, if you put the negative up top, you're going to have to put parentheses around it. Otherwise, just putting the negative right in front of the y is going to be an incorrect answer, because it's only going to negate the y. So I can write my answer this way, or I can write my answer this way. This is probably a little bit more traditional. Let me go ahead and get rid of this part then right off the bat. Now when we add and subtract fractions, remember we must have common denominators. Common denominators, the only way you can add fractions, the only way you can add rational expressions. So if we have common denominators, we add the numerators, keep the same denominator. If we subtract the numerators, keep the same denominator. You can see in both of the examples that I have here, neither has common denominators. This denominator and this denominator of 9y squared and 15y respectively are monomials, and so what I'm going to do here to find my least common denominator, the LCD, remember this, is to look at each one of these in terms of factors. This is 3 times 3y squared, this is 3 times 5 y to the first. I have 3's, I have 5's, and I have y's. I have 3's, I have 5's, and I have y's. 3's, I have 2 factors of 3 in this denominator. I only have 1 here, so if you take the most times it's used, and that is used twice in the first one. 5, I don't have any 5's here, but I have 1 5 here, so the most it's used is once. Y's, I have 2 y's here, I have 1 y here, so the most it's used is twice. 3 times 3 times 5 is 45. Y squared is my least common denominator. So I'm going to rewrite this with 45y squared as my denominator. The next one's even going to be more fun, because we're going to have to do some factoring first. Now what did I multiply times this denominator to change it into my LCD of 45y squared? Well, I multiplied it by 5. So if you multiply the top or the bottom by 5, you have to multiply the top by 5 as well. In this particular denominator, to change into this denominator, I'd have to multiply the 15 by 3, but I'd need an extra factor of y. I multiplied it by 3y, so I have to do the same thing to the top. 1 times 3y is 3y. Now I can add my numerators, put it all over my common denominator. 40 plus 3y, I like to write 3y plus 40 instead because I like the descending order effect. Now I would look to see if this simplifies. My numerator does not factor, my denominator does not factor. This is a completely different factor than what I have anything in the bottom here. You can't cancel the 3 with the 45. Don't even look at it that way. You can't cancel a 5 with the 40 and the 45. Remember, the 3y is a term, the 40 is a term. You can only cancel factors. In the next example, I have subtraction. You have to be a little more careful with subtraction because of the subtraction sign affecting the signs of what you're subtracting. But before I can get really going after this, I'm going to factor both denominators. When I see this coming, and I'm working out this problem on paper, most times instead of writing it in this form, I'll write it into the factored form to save myself a step of work. Now that I have all my denominators factored, I look to see that I have a t plus 2, I have a t plus 3, I have a t plus 1. I'm trying to find my LCD here, and I have these 3 different factors. T plus 2, I have 1 factor of it in this denominator, 1 in this denominator. The most it's used is once. Not the total, the most times it's used. T plus 3, once here, no times here. Once is the most. T plus 1, no times here, 1 time here, the most. So it's going to be the quantity t plus 2 times t plus 3 times t plus 1. You can put those in any order because you're multiplying here. So this is t plus 2 times t plus 3 times t plus 1, t plus 2 times t plus 3 times t plus 1. And what would you multiply times this denominator to turn it into your LCD? Well, it's the factor of t plus 1. So you multiply the bottom by t plus 1, you multiply the top by t plus 1. T times the quantity t plus 1. You can go ahead and distribute if you'd like. Over here, to get this denominator into this, I multiply by the factor of t plus 3. So t plus 3 up here, that gives me 2 times the quantity of t plus 3. Now I'm ready to start thinking about subtracting my numerators. I still have to be careful because neither numerator is simplified. So I'm going to do that in this step here. And I hope that I have given myself enough room. So this would be t squared plus t minus, this is like a minus 2, a negative 2 that I'm distributing by. So that will be minus 2t minus 6. Well, that gives me, let's see if I can get this all written in here. When I combine like terms in my numerator, I have t squared, t squared minus t minus 6. Well, fortunately for me, this numerator factors, because I want to see if I can simplify this. This factors into t, looks like minus 3 times t plus 2. Well, it is a very good thing that I took the time to see if this simplifies by factoring the numerator, because I have common denominators. Now these, common factors. These are not the same, these are not opposites. These are conjugates, they don't cancel. But the t plus 2 and the t plus 2 do. And so they cancel as factors of 1. So t minus 3 times 1 is t minus 3 is my numerator. 1 times t plus 3 times t plus 1. That's my denominator, and that's as far as that simplifies.